Standard form equation, my a value is 3. Because it's positive, it's going to open up. Now, with standard form equations, we always find the vertex first. Now, this is my previous setup, so we need to change. We do need to do some work outside. So the formula for the vertex is negative b over 2a. So the b value is 5. So you're saying the formula has a negative, the b is a 5, 2 times 3. So you end up with negative 5 over 6. So the vertex is roughly around negative 0.8 for the x value. So I'm going to say my x value is negative 0.8. Now every vertex has an x and a y because it's a point. I already know my axis of symmetry is negative 0.8. Now if I need to find the y, I need to use the formula to get my answer. So it's 3, and then I'm going to plug in the negative 0.8 squared plus 5 times negative 0.8 plus 2, and it gives you roughly around negative 0.08. So this one goes here. If you graph that, you're going to do the initial sketch at negative 1.8. So this is negative 0.8. And this is negative 0.08, which is a really small number. It's really close to the x-axis. And it is a positive 3, so it does open up. So we expect to have 2 solutions here. Now the y-intercept, because I am in standard form, is really just my c value. So I know it's y is equal to 2. But if you forget that, just plug in x equals to 0 and you get the same way. For this one, because it does have a non-1 value as a, I'd rather you do factoring. So a times c is 6. What does 1 make 6 that combines to 5? I think that's 3 and 2. So 3x squared plus 2x, by 3x plus 2x plus 2. This right here have a 3x in common, so you end up with x plus 1. This one's have a 2 in common, so you end up with x plus 1. So one factor is x plus 1. The other factor is 3x plus 2. The zero product rule says I need to separate them. X plus 1 equals to 0, and 3x plus 2 equals to 0. X must be negative 1. And minus 2, 3x is equal to negative 2. Divided by 3, x must be negative 2/3, or about negative 0.7. Now the domain for all quadratics is always the same. It's always getting wider and wider to the left, to the right. And so my final graph starts over here. I have a really weird vertex, which is negative 0.8, right? And negative 0.08, the really small number. I'm going to be crossing at y2. And my x values is negative 1 and negative 0.7. So it's really, really close. Everything's just really close up. And there we go. Oh, my range is from this point and up, from this point, which is the same as my y value. So it's negative 0.08 to infinity, not including this number, but not infinity.